Hey everyone, welcome back to the deep dive. We're going to be simplifying things. We're going to be talking about simplifying AI acceleration.
Okay, feels good.
And we're going to be specifically looking at CEREBRAS systems and their approach to doing that with basically a single giant wafer of silicon.
Yeah, it's really a pretty radical shift, I think, in thinking. It's instead of connecting lots of individual processors, it's almost like they built one massive one. So, imagine like the complexity of like coordinating an entire city of computers versus like the organization of a single, enormous building.
Right, yeah. Is wafer scale integration.
Yeah.
Like putting a huge amount of processing power and memory onto one silicon wafer.
Exactly, yeah.
So our mission in this deep dive is to understand how CEREBRAS simplifies AI processing, especially if we just like take cost out of the equation for a moment. So let's unpack this a little bit. Traditional AI scaling often involves clusters of graphics processing units, GPUs. What are the coordination challenges that CEREBRAS is really designed to avoid?
Yeah, so if we connect this to the bigger picture, think about the communication between many individual GPUs. You have to manage data moving across, different cards through cables, and it often leads to these bottlenecks. And you need some pretty sophisticated software to keep everything synchronized. CEREBRAS, by having everything on one wafer, fundamentally bypasses a lot of that, like all that inter-chip communication complexity.
So it's all just like super direct, and like the connections are incredibly short because it's all on one piece of silicon.
Mm-hmm. Yeah, precisely. Imagine like the communication fabric as just like an incredibly dense network of pathways built directly onto that single wafer. Data can travel much, much faster compared to going between, separate chips. And this approach, because it's so integrated, naturally leads to a more straightforward programming model. And that is a significant advantage when you're dealing with today's, truly massive AI models.
Right. So you're not wrestling with the intricacies of like making like tons of individual processors all work together seamlessly.
Right. Exactly.
So let's talk about speed for a second. AI needs to process tons of data quickly. How does this design help accelerate that?
Yeah, I think the crucial thing here is bandwidth and latency. So bandwidth is the amount of data you can move, and latency is the delay in that movement. And in traditional systems, data might have to travel across, the motherboard through network interfaces. But with CEREBRAS on wafer communication, you get incredibly high bandwidth and very low latency. So it's almost like moving information, within one giant chip rather than, across a city. And this drastically speeds up the processing of, really, really complex models.
Fewer data traffic jams.
Exactly, yeah.
Got it. Another key element is memory. Big AI models require tons and tons of memory. So how does CEREBRAS simplify things in that area?
Yeah, this raises a really important question about data access. The sheer size of the CEREBRAS wafer allows for an enormous amount of on-chip memory. Think about it in terms of scale. Like this single wafer can hold far more memory, much closer to the processing units than, many individual chips combined. And this means you can store entire AI models, or at least very large parts of them, right there on the wafer. You reduce the need to constantly pull data from slower external memory, which simplifies the process and boosts performance.
Less need to go fetch data from elsewhere. Just keep everything local and fast.
Yeah, exactly.
We often hear about data parallelism. How does CEREBRAS leverage this in a way that's less complicated?
Yeah, absolutely. So data parallelism is essentially, taking a big data set and giving different chunks of it to different processors to work on, simultaneously. It's generally considered the easiest way to parallelize computation. Now, because CEREBRAS packs so much interconnected compute onto one wafer, it's exceptionally good at exploiting data parallelism. And this often means that you can avoid the added complexity of what's called model parallelism, where you have to split the AI model itself across multiple processors and coordinate how those parts work together. So CEREBRAS scale can often just handle the entire model, making things simpler.
Okay, so let's just kind of recap the simplification. CEREBRAS consolidates a massive amount of compute and memory onto a single wafer. This leads to faster internal communication, less reliance on complex distributed processing, and an easier time using straightforward parallel processing techniques like data parallelism.
Yeah, that's a really, really clear summary. I mean, if we bring it back to our initial point about cost not being the primary concern, Cerebras offers a very direct and, in many ways, less complex route to, high-performance AI acceleration, particularly for those, truly massive computational tasks where traditional scaling becomes a significant engineering challenge.
Well, yeah, the big takeaway is that while it might be, a premium approach, wafer scale integration offers a uniquely simplified path to tackling some of the most demanding AI workloads out there.
Absolutely, yeah.
So for a final thought, imagine if manufacturing breakthroughs made these massive single wafer systems, much more accessible.
Mm-hmm.
How might that change how we think about and deploy AI in the future?
That's a fascinating question. I mean, it really makes you consider the potential for like a dramatic evolution in AI computing paradigms.
Indeed. Well, thanks for the deep dive. Until next time.